Hello everyone, so today we're going to go over section 6.3 part A, trigonometric ratios. So first, recall that the three trigonometric ratios are sine, cosine, and tangent. And of course, sine theta is equal to opposite over hypotenuse, cosine theta is equal to adjacent over hypotenuse, and tangent finally is equal to opposite over adjacent. So combine that with what we know about the unit circle centered at 0, 0, or just any circle really. We have the following. Here we have that the x-coordinate is x, the y-coordinate is y, so we have a right triangle here. The angle that we're looking at is theta, the angle in standard position, so we will have the following trig ratio for sine theta. We have y over r, opposite side of the angle is y, and the hypotenuse is r. Okay, so let's write that in. Likewise, for cosine, we have x, which is the adjacent side, over r, the hypotenuse. So that will be our second trigonometric ratio here. And finally, for tangent theta, we have y over r. The opposite side to the angle theta is y, and the adjacent side is x. In the case of the unit circle, where r is equal to 1, then the three ratio simplifies to sine theta would just be equal to y, since r is equal to 1. Cosine theta would just be equal to x, and tangent theta remains the same, and that will be y over x. Now we can also write tangent theta as a quotient of the two trig ratios, sine and cosine. So this would be sine theta over cosine theta. And this is true for not just the unit circle, but for any radius r as well. Since the radius will eliminate each other if we were to write sine theta over cosine theta. So we'll just reduce it to y over x, which in turn will reduce to just tangent theta. Okay. So this would be the three trig ratios. Now, there are an additional three trig ratios that we can look at. They are the cosecant, secant, and cotangent ratios. And as we can see here, the first of the three, the cosecant, is equal to 1 over sine. So given what we just saw, this would be equal to 1 over y if the radius is 1. And then secant will be 1 over x. And finally, cotangent, which is 1 over tangent theta, would be x over y. Alternatively, we can write this as cosine theta over sine theta as well. So important to note as well that when we are looking at tangent, and also the reciprocal trigonometric ratios, since we have denominators like x, cosine theta, y, x, and then sine theta, the restrictions will have to be applied where those numbers are not equal to 0. Sorry, those variables are not equal to 0. So here, for example, y cannot be equal to 0, x cannot be equal to 0, and sine theta cannot be equal to 0 either, and also cosine theta cannot be equal to 0 here. Okay. And similar restrictions. Here, cosine theta cannot be equal to 0, and here, sine theta cannot be equal to 0. Okay. So, the next question will allow us to find some trigonometric ratios given the point on the terminal arm on a unit circle. So here we have point A, which has coordinates -3/5, 4/5, which lies on the intersection of the unit circle and the terminal arm of angle theta in standard position. So just to confirm that this point is in fact on the unit circle, we can have x squared plus y squared equals to 1. So then we can substitute in -3/5 squared, and then we add 4/5 squared. And that will be equal to 1. So -3/5 squared is 9/25. And of course, 4/5 is squared is 16/25, and that does add up to 1. So this point is in fact on the unit circle. Okay, next we're going to draw the angle in standard position here. We know that the since x is negative and y is positive, that the angle will be in quadrant number 2. So something that looks like this. Okay. So here we have the y value will be 4/5. The x value is -3/5. The hypotenuse is 1. So we can use this to determine our trig ratio. So in the first case, since this is a unit circle question, sine theta is equal to the y coordinate, which of course is just 4/5. Cosine theta is equal to the x coordinate, which is -3/5. And finally, tangent theta is going to be equal to y/x. So that would be 4/5 over -3/5, which simplifies to -4/3. And then we have the reciprocal. So the first one, this is simply 1/y. So the cosecant theta will be 5/4. Okay, secant will be 1/x, so we'll have -5/3. And finally, cotangent will be x/y, which will give us -3/4. Okay, so next we can look at the values, the exact values of some trigonometric ratios. So we have here, for example, sine 150 degrees. So first thing we're going to do here is to draw 150 degrees. That, of course, will be in quadrant 2. And these numbers here, these lines that are drawn, they're actually 30 degrees, 45 degrees, and 60 degrees respectively. And of course, this line is 90 degrees and so forth. So using these lines, we can find that the terminal arm of 150 degrees must be here, since this angle is the reference angle of 30 degrees. And then the other side, of course, is the 150. Okay, and then using what we know about the special triangle, we know that this opposite side is going to be 1 over 2, and this adjacent side is going to be negative root 3 over 2. Sorry, that's a little bit hard to read. Let's put over here, negative square root of 3 over 2. And again, the y value is the 1/2. So since sine 150 degrees is equal to the y coordinate of this point that we just found, which has x equals to negative root 3 over 2 and y equals 1/2, then sine 150 degrees is simply just 1/2. Okay, so the next one, very similar, pi over 3. Right, we should write that down here as well. 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. So this is where our terminal arm is going to be. And again, we have the 30, 60, 90 triangle to work with, which, because this is in radians, this is the pi over 6, pi over 3, and pi over 2 triangle. So very simple question to look at. So again, we are looking at this y value and this x value. Using the special triangle, we know that this x value is going to be 1/2, and this y value is going to be square root of 3 over 2. Should draw in the angle here as well. This is pi over 3. So in this case, we have cotangent pi over 3. Cotangent, of course, is x over y. And so we have 1/2 over root 3 over 2, which simplifies to just 1 over root 3, which of course can be rewritten as root 3 over 3 if we rationalize the denominator. Okay. So the pattern to these questions is to first draw the terminal arm, find out the correct special triangle to be using, write down the sides of the special triangle, and then find what x and y value those are, and finally figure out what the trig ratio is. So again, here we have another 60-degree question. So here's the terminal arm. Okay, so the same right triangle as the previous question. Again, we have x is equal to 1/2, y is equal to the square root of 3 over 2. And this angle here is 60 degrees. Okay, so this time, the trig ratio to be considered is cosecant of 60 degrees, which we know is 1 over y, which means we're going to have 1 over, and then the y value was square root of 3 over 2. So we take the reciprocal of that number, and we get 2 over root 3. If we were to rationalize the denominator here, then we'll get 2 root 3 over 3. Okay. Next one, 3 pi over 4. So 3 pi over 4 is going to be 135 degrees if we were to rewrite it in degrees, which makes it in quadrant number 2. And the reference angle, of course, is 45 degrees, so that's how we know to draw it here. So the angle here this is 3 pi over 4, and the reference angle is pi over 4. So in this case, we actually use the 45, 45, 90 triangle, or the pi over 4, pi over 4, pi over 2 triangle. Let's go ahead and draw that in. So here the sides are both going to be 1 over root 2. The x value is going to be negative since this is in quadrant number 2, so negative 1 over root 2 here, and then the y value of 1 over root 2. Okay, and once we have that, we're looking at cosecant once again, and that's, oops, sorry about that, cosecant 3 pi over 4. So that's going to be, once again, 1 over y. And we know the y value is 1 over root 2, so we have 1 over root 2. And the reciprocal of 1 over root 2, of course, is just the square root of 2. And that's it. So from there, let's look at a couple more. Tangent 315 degrees. This one is going to be in quadrant number 4. Since 315 is 45 degrees short of 360, so here's our terminal arm. Let's go ahead and add that in first. Okay. So once again, we need to use the reference angle. This time the reference angle is 45 degrees. Since the angle itself goes counterclockwise this way, so 315. And as we said, this is 45 degrees short of full rotation. And so once again, this is a 45, 45, 90 triangle question. So the y value this time is going to be negative 1 over root 2. However, the x value is going to be 1 over root 2. Okay, so we're looking at the tangent ratio this time. So this is tangent 315, which of course is equal to y over x. And that will be 1 over root 2 over 1 over root 2. Sorry, the y value is negative. And then we have 1 over root 2 in the denominator. And so this will just simplify to negative 1. Okay, lastly, we have secant pi. So pi, of course, is 180 degrees, so the negative side of the x-axis. The coordinates of this point here is simply going to be negative 1, 0. We don't need a special triangle for this question. And so, in this last part, secant pi is equal to 1 over x. And we can see here the x value is negative 1, so this is simply going to be 1 over negative 1, which gives us negative 1. Okay, so that's it for the kind of no calculator part of this. We use the special angle triangle to find what the trig ratios must be using a combination of the unit circle, again with the special triangle. The other part of this is about using a calculator to find approximate values of trig ratios. So there are, of course, angles that are not special triangle angles, 40 degrees, for example, and then negative 50 and things like that. Likewise for radians as well, 2.5 radian, for example, is not a special triangle number. And for those ones, we will need to use a calculator for it. And the idea here is to be familiar with the calculator that we need to use for class, and that's it. So that's the first part of section 6.3, and that's it for today. So thank you for listening.